Hey team, welcome to the numbers game. I'm Coach T, and in this tutorial we're going to be evaluating and analyzing the continuity of a function. Now before we get started, make sure to subscribe to the channel for more math tutorials. Alright, now let's take a look at our example. So in our example we have this piecewise function where f of x equals x squared if x is rational, and f of x equals 3x if x is irrational. And we're asked to prove that f is continuous at x equals 0 or x equals 3 and is discontinuous at x does not equal 0 or x does not equal 3. In this tutorial, we're actually going to be proving the second part of our condition, which is that f is discontinuous at x does not equal 0 or x does not equal 3. I will put a link somewhere in here to the other tutorial where I go over how to prove that f is continuous at x equals 0 or x equals 3. Okay, so I went ahead and graphed our function. X squared should equal 3x if and only if x equals 0 or x equals 3. Now, as I mentioned in this tutorial, we're going to be proving that f is discontinuous at x does not equal 0 or x does not equal 3. So for us, we need to show that x squared does not equal 3x if and only if x does not equal 0 or x does not equal 3. Alright, so let's move on to our proof. So again, in this proof, we're going to be showing that f is not continuous at any point p where p does not equal 0 or p does not equal 3. And to do this, we're going to need to use a particular theorem. And here it is. The theorem says the function f is continuous at p if and only if for any sequence x sub j which converges to p, the sequence f of x sub j converges to f of p. So as you all have probably guessed, we're going to be using limits to evaluate convergence. So the first thing that we'll do is let p not equal 0 or p not equal 3. And because we were given a piecewise function with two separate conditions, we're going to use two separate cases in this proof. We'll start with case 1. That will reflect the first part of our piecewise function, and that was p is rational, p does not equal 0 or p does not equal 3, then our function f of p equals p squared. Okay, I'll scroll back up for you all to be able to see that. The next thing that we'll do is let the sequence x sub j be a sequence where each x sub j is irrational and the limit as j approaches infinity of x sub j equals p. Now for us, the limit as j approaches infinity of f of x sub j is the limit of 3x sub j, which in our case equals 3p, and this does not equal p squared. And p squared is our f of p. Alright, now let's move on to case 2. Case 2 states that if p is irrational and p does not equal 0 or p does not equal 3, then f of p equals 3p. And now we'll let the sequence x sub j exist, and each x sub j is rational, and the limit as j approaches infinity of x sub j equals p. Now the limit as j approaches infinity of x sub j equals the limit of x squared sub j, which equals p squared, which does not equal 3p. And 3p, of course, is f of p. Thus, we have proven that f is not continuous at p. And there you have it. We've proven that our function is discontinuous at x does not equal 0 and x does not equal 3. If this video was helpful for you, give it a thumbs up, like it, and subscribe to the channel for more math tutorials. I'm Coach T, and thanks for watching the numbers game.